And very happy to introduce Peter Goodhand to our today's lecture series. He is the Chief Executive Officer of the Global Alliance for Genomics in Health. The Global Alliance, and we will learn more about it, is an organization that enables responsible genomic data sharing by framing policies and setting standards, technical standards for genomic data sharing. We know each other from the regular and ethics working stream, a work stream that has, as many others in the Global Alliance, developed solutions and standards for data sharing. And Peter played a critical role in bringing Global Alliance for Genomics in Health forward from the early days to a large now and global acting research platform. Previously, Peter served as a president of the Ontario Institute for Cancer Research and CEO of the Canadian Cancer Society, and was, before he joined this charitable sector in the global medical technology industry, and has also, and that is interesting, since we are working in the rare disease community a lot with the global, with the German GHGA, also a 12-year experience as a patient advocate in the rare disease area. So we are very curious and honored, Peter, that you share with us your experiences in setting standards and framing policies for genomic data sharing.
Thank you, Eva.
Yours is the floor.
So Jan and I have been working on making sure this presentation works for, seems like the last 24 hours, but not quite. But if you could bring up the slides, Jan.
Yes.
Usually at this point, I have to say good morning, good afternoon, good evening, but for once, I'm also on Central European time. So same part of our working day for me. I couldn't resist the juxtaposition of our two acronyms. When we started Global Alliance, we were worried that there were 28 other groups that started with Global Alliance, but then for a whole bunch of other purposes. But this is the closest we've ever come to acronym overlap, so I had to call it out. Next slide, please. I apologize to those who have seen the GA4GH talk before. I know some of you have probably seen it several times, but I thought I'd just shape the whole of our journey and then hopefully in the end get into some of the more forward-looking things that we're working on today. But we've been around since 2013. We really got up and running in 2014. And the mission has really not changed over those 10 years. It never was about bigger, faster, better genomic research. This was people who were doing genomic research saying it is on the cusp of being able to impact human health. The cost of sequencing is coming down. The knowledge we're unwrapping from the genome is increasing. This will be genomes in every country, every city, every university, and in healthcare. So we need to organize this field in a way that can become a treasure trove of human data, not a tsunami of noise. And so this mission statement, which has had both the ethical approaches, the policy, and the technology to move from genomic research into healthcare, has been there from the very beginning. Next slide. We do that. We've always been focused on international data sharing. Some of our projects are focused within a national initiative, but they are keen to share with other national initiatives. We've also focused, we said, across the translational continuum. I think in the beginning, we thought it went from basic research, translation, clinical to healthcare in a linear fashion. Today, we think of it much more of a learning health system and of a circle of knowledge, and that from healthcare, we can go back to research and keep increasing that. Increasingly over the 10 years, we've looked at more and more federated approaches, but throughout, we've always been focused on interoperability. I won't read them, but you can see on the right-hand side, we do that in many ways. Next slide. We're now going to try the most technically difficult part of this presentation. We've used animated videos and we've translated
In
them
den
into
nächsten
multiple
10 Jahren
languages.
werden viele Millionen Menschen ihr Erbgut aus gesundheitlichen Gründen sequenzieren lassen. Dieser Schatz an Informationen kann die genomische Medizin verändern und die biomedizinische Forschung beschleunigen, allerdings nur, wenn er auf globaler Ebene erforscht werden kann. Die Daten der einzelnen Disziplinen, Institutionen und Länder sind oftmals voneinander isoliert. Ohne standardisierte Verfahren für die Erfassung, Speicherung und den Zugriff auf Daten ist die Zusammenarbeit zwischen verschiedenen Wissensgemeinschaften schwierig. Die Lösung? Die Global Alliance for Genomics and Health. Diese globale Allianz wurde 2013 gegründet, um einen verantwortungsvollen und sicheren Austausch von Genomdaten über Wissensbereiche, Plattformen und Grenzen hinweg zu ermöglichen. Durch diese Zusammenarbeit können wir unser Verständnis des menschlichen Genoms erweitern und ansonsten unheilbare Krankheiten behandeln. Auf der Grundlage der Allgemeinen Erklärung der Menschenrechte setzt sich die GA4GH für das Recht aller Menschen ein, am Nutzen der Genomforschung teilzuhaben. Zu diesem Zweck bringt GA4GH eine globale Gemeinschaft von Forschern, Softwareentwicklern, Gesundheitsdienstleistern, politischen Entscheidungsträgern und Patientenvertretern zusammen, ein vielfältiges Netzwerk von Partnern, die den Wert des Austauschs genomischer Daten zum Nutzen der menschlichen Gesundheit und der Medizin verstehen. Unsere Gemeinschaft hat sich in 8 Arbeitsgruppen organisiert. Sie entwickelt und befolgt Standards und Richtlinien, die für die Beschreibung, Entdeckung, Speicherung, den Zugriff, die Übertragung und den Schutz von Genomdaten zur Förderung der freien Wissenschaft erforderlich sind. Jeder Arbeitsablauf stützt sich auf Beiträge von Kernprojekteninitiativen, die unsere Arbeit an realen Bedürfnissen orientieren. Die von und für die genomische Forschungsgemeinschaft entwickelten GA4GH-Standards ermöglichen ein grenzüberschreitendes Ökosystem von Daten und Instrumenten, das den wissenschaftlichen Fortschritt im Bereich der Humanmedizin zügiger voranbringt.
Thank you. And we can move to the next slide. I will put a little bit more depth onto some of the points made, but really the reason I wanted to show you that video is we're trying very hard to be global. And we recognize that genomic research typically is conducted worldwide in English, but the closer we get to healthcare, the more we want to engage with patients and others and policymakers, the more important it is that we can explain who we are in a variety of different ways and languages. So we have one more video coming up later for that. I hope our German translation was a good one. This is our timeline. I actually joined in 2012, and so it's 11 plus years for me. 2013 was all about bringing leaders together and shaping the vision. And we released that vision in the middle of 2013 in a white paper. Again, I won't go through all of the timeline, but if you look at that bottom stage, we've almost been like a startup company. And we got some seed funding from a few host institutes, and we just got going. We knew it was urgent. We knew the field was changing quickly. And if we spent all our time in planning and talking and preparing, we'd always be catching up. We'd never be moving forward with the field. So we focused on getting stuff done, of being grounded in the real world, not just creating standards to sit on a shelf. So first phase was all about building momentum, creating a community, getting the right people together, and perhaps more than anything else, building the trust amongst those collaborators that they could work effectively together. When Ewan took over in 2017, it was part of our time to grow up. We needed to be more disciplined. We owned up to being a standards body. I think before that, we were almost a social movement. So we focused on productivity and output. We created a new model of work streams and the driver project connection. That first phase, we created our own demonstration projects. I'll show you in a minute. We're now gone from 3 demonstration projects to 28 driver projects next year. We did a check-in with the community back in 2021, to really say what have we done well, what we haven't done, what should we be doing better. And it created 3 strategic imperatives. Make sure the standards and the APIs and the protocols can work better together. Create interoperability so we can achieve our goals using multiple standards. Make the individual standards, the protocols, easier to implement, particularly in low resource settings. So give us more guidance, more documentation, more test beds, more reference implementations, so more people can apply them. And thirdly, get closer to healthcare. We just repeated that process again, and I will say that those 3 strategic imperatives are still driving us today, but now with an emphasis on put active, concrete things in place to be able to make those things happen. So we've identified them, we talked about them, we planned. Now make sure we're doing active work to deliver on those imperatives. Next slide. Eva mentioned she'd been involved in the early days with our ELSI work, which today we call RUS, Regulatory Ethics Workstream. Perhaps more than anybody else, Bartha Knopfers led us to this embracing and grounding our framework in the Universal Declaration of Human Rights. Right to science, the right of all humans to benefit from science, and the right of scientists and others to benefit for recognition of their work. And I think today we would extend that recognition to the patients, the participants who donate their DNA for research, as long as everybody along that chain. So we've modified our interpretation of it, but still those 2 fundamental rights. Next slide. Those rights were used to create the framework for responsible sharing of genomics and health-related data. It's now been translated into 14 languages. The important thing is a very high-level document, because we know that regulation and policy is often set at a national level. And so this is a reference document that anyone working in this field, anywhere in the world, can look up to and say, as we shape what we're doing in Sri Lanka, in South Africa, in Germany, this is an overarching document that we can see that the rest of the world is referencing to, but we will have to customize it in our own way. This group is probably the most active of our 8 groups. So although it's 7 technical groups and 1 ELSI group, this is probably equivalent to 3 of the technical groups in the number of people and the outputs. So they have now produced multiple products, consent documents, policies, implementations. Next slide. It's a big community. So we've got core funders based in the US, UK, and Canada who support the host institutes in those countries. I'm based at the OICR in Ontario, Canada, but the others are Sanger, Broad, and BI. We've got supporting funders, mainly industry. We're increasingly trying to get that global reach. So we're recognizing a lot of countries, they cannot send money to GA4GH, but they can employ people locally, dedicate people locally to be part of this global effort. We have 1 official strategic partner at the moment, which is Elixir, and we're forming strategic relationships with other large groups, including NIH. These are the 28 current driver projects. I think I might have a slide that shows them in a bit more detail. But just to give you a sense of scale, when we started 10 years ago, I think there were probably 10 to 15,000 whole genomes in the world. These driver projects will represent over 3 million whole genomes just in these 28 projects. And we know there are over 200 projects worldwide. Our work streams will collaborate with any group who's interested in participating. So you do not have to be a driver project or connected to a driver project to impact and input on GA4GH work streams, but they are our strongest community of influence. Next slide. We've gone from 73 initial partners signed the letter of intent. It was really just, yes, we think this is a good idea, we'll get on board when you're ready, to today over 500 organizational members. About half of those are industry, rather than academic, but our biggest influence by far are the projects I just showed you on the previous page. Next slide. This is what we call our ecosystem. So I'll start with the bottom. There's 450 active contributors. We've got about 4,000 individuals all told, a part of our system, but about 450 active contributors from 100 countries. They have produced the 28 driver projects I've already mentioned. We collectively now put out 44 GA4GH products, either technical or regulatory and ethics, and we're tracking over 200 implementations. And I will say it's probably many more than that, because GA4GH file formats include BCF, CRAM, BAM, BED, and I don't know anybody who's not using one of those in their genomics work. So when we say implementations, I think we're focused on the things we've actually created rather than the legacy standards we inherited. Next slide. Already said, strategic partner, just one at the moment. We'll look for more. Driver projects, organization members, signed experts, individuals. That's the community. Here's what we do. So we define the needs. We rely very heavily on the driver projects to tell us what are the most important things to be working on. We do not want to be working on theory or things that are not needed today, but are 5 years away. But we do want to be focused on what's needed today and next year and the year after. We want to do it in real time. So once we've defined there's a need through our study group process, we then move into creating the standards. Hopefully that takes a year or less. Complex ones can take a bit more. And then we move from creating the standard inside the work streams into implementation. And that's critically important for us, because in order to improve those standards, make sure they're fit for purpose, give versioning, we need feedback from the implementation community. We have several implementation communities, particularly the National Initiatives Forum, and also communities of interest. There are lots of ways for GHGA, I have to be very careful when I say your acronym, to get involved with Global Alliance. And I would say particularly national initiatives is a natural. Next slide. These are the 8 work streams. We've already talked about regulatory and ethics. It, along with data security, is seen as foundational. They have, not only do they produce their own work, but they also have an approval mechanism over the work of the other 6 standards. So those 6 technical groups that you can see on this slide, their products, when they're approved by the steering committee, there's got to be a sign-off from regulatory and ethics and a sign-off from data security, that not only are they good standards, but they've addressed appropriately regulatory ethics and security issues. Next slide. So I said earlier that the biggest, most active of our groups was regulatory and ethics workstream. Here, and also translated, is that, well, the framework is translated, the rest of this slide isn't. But here's some of the projects that they've either just been working on or are currently working on. Not all of them will be relevant to your work, but I'm assuming that many of them are. And again, it's not saying you've got to take it exactly as it is and apply it. It's how can we use this as a reference document as we create what we need inside GHGA. Next slide. These are the 10 new driver projects that we've just announced. A few have completed their work as projects and have stepped back, but we just did an open call, and these are the new ones coming in. There's still that heavy emphasis on rare disease and cancer, but it is broadening. And it's also bringing in clinical data sharing in that IPCHIP, the International Precision Child Health Partnership. It's pediatric hospitals in 4 countries wanting to share in-depth data. So it's more of a healthcare focused one than we've ever seen. Top left, Biomedical Research Hub is a huge initiative out of the University of Chicago using the Gen 3 platform, but very much in the world of data mesh and data fabric conception. And as you can see, we've got a little bit broadening of our geographic reach with the Qatar Genome Project. But perhaps the biggest spread or new initiative for us is the Human Pangenome Project. And this is working with the team that have developed the telomere to telomere work and have done the Human Pangenome Reference Consortium in the US. They want very much to make sure it's not seen as just a US project. And so we're working with them on globalizing a project that up until today has been essentially a US funded and delivered project. Next slide. 28 in total, 10 new. And as I said, over 3 million genomes. You'll see the European Genome-Phenome Archive in there. Lots of conversations at the moment. I go next week to the GDI meeting in Barcelona. GDI also another new Global Alliance driver project. So a lot of the work that has taken place over the last 10 years is now actually being put into practice, and not in individual places, put into practice across national boundaries at scale that we couldn't have imagined. So I think it's this community is where we're grounded. But I really want to stress to GA, you can fully participate in GA4GH directly and through your relationships with others on this page. Next slide. And I've just highlighted of the 28. These are ones that are based on this side of the Atlantic, so in this time zone. And I know there's some complex relationships today between Europe and the country of my birth, but I put UK and Europe side by side. So a good representation from this part of the world, however we define it, and obviously a strong participation from the US. And I spend most of my time today trying to put the global in the Global Alliance, because it's been relatively easy to form an Anglo plus Europe alliance. It's much more difficult to get to the global south and get full engagement on a global basis. But we're working on it. Next slide. So when we put all those driver projects and every touch point we've got together, this is our global reach today, active in 113 countries. But that's really through partners and through relationships. It's not that heavy, concentrated activity when I know we've got real people on the ground, people working with us, chairs of our working groups, multiple institutions, all participating. So when we look at that slide, next, the world shrinks in terms of countries where we've really got a lot of presence, a lot of activity. Fortunately, from a global map perspective, we've got Canada, US, and Australia, and Brazil. So that gives us some really big geographic countries. But if you did this by population, we're missing huge parts of the global population. And I would really hope we can, through this collaboration, we can make Germany a very strong contributor across not only GHGA, but other groups and active within it. Next slide, please. Beyond our work streams and our driver projects, in the last few years, we've realized that some of those driver projects come together and say, we're all cancer, or we're all rare disease groups. But outside Global Alliance, there are many others in our world who should know about these standards and should work with you. So these communities have typically been mobilized inside the driver project communities, and then they've reached out to their broader domain community. Cancer is our most established one. We formed infectious disease in response to the pandemic. Rare disease spun up at the same time, although rare disease individual projects have been with us from the very beginning, including Matchmaker Exchange. And then, which should be of interest to your next lecture speakers, we must say Matchmaker Exchange to them. And we're just in the process now of forming a neuroscience community. So they look for commonalities across their domain. and say, as we were implementing this or as we were doing this, we found a huge piece missing from the cancer perspective. Can we put that on your agenda? It goes forward the study group and we look at a new project. So another mechanism for things to advance inside GA4GH. Next slide. I mentioned national initiatives. About 4 or 5 of them are driver projects, but there are over 20, probably 30 by now, countries that are saying we are going to do something at a national scale. It could be a population cohort, like all of us in the US. It could be a precision medicine transition from research into healthcare, like Genomics England. The Singapore One Precise is a new member. It's doing great work, and it's leapfrogging over some of the work that's been done by others. It started later. It gets the advantage of copying really well. So this community of groups that are either taking a national perspective, or in case of Seneca, Europe, Canada, and Africa, but a large-scale initiative. Not so much driver projects, although some of them are, but these are more of an implementation community that as they're implementing inside their country and working with other members of this page, how can we create new standards or improve the standards we've got? So another critical community for us. Next slide. This is where I spend a lot of my time, because outside GA4GH, there are many other groups in the world doing genomics at scale. And I probably should now take beyond 1 million genomes and human pangenome off the slide, because through GDI and the Human Pangenome Project, they've actually come inside our driver project. But we've been working and talking to them for the last 2 or 3 years as parallel organizations. Not sure if you're aware, but the WHO formed a science council about 3 years ago, and its first report was on genomics and how to try and use genomics in all countries, including low middle income. And a recommendation was to set up an advisory group on genomics. And I met with them a few weeks ago in Geneva. So their technical advisory group, genomics. So WHO is paying attention to genomics and not just on the pandemic and the infectious disease. Next slide. I mentioned earlier, we switched the concept of a 15 to 20 year process of things from research to translational to clinical to practice, healthcare practice, in the linear fashion. And today, what we're promoting and hoping and advocating for is more of a learning health system in which not only does knowledge come from research into healthcare, but we can data mine knowledge out of it. Healthcare, complicated. It's got all kinds of privacy, security issues. We need to think about data exhaust rather than having busy clinicians doing more work. But the creation of learning health systems, I don't think a learning health system will work on a global scale. I think it will be a German learning health system and a Canadian learning health system. What Global Alliance can do is find ways, particularly for things like rare disease, or the meeting I've just been at, pediatric cancer, where no one country has enough to create the knowledge and the learning. We'll look for learnings across borders. But there is a very different mindset. So as you all know, genomic research has been international for 30 plus years, all the way back to before the Human Genome Project. It's been naturally organized on an international basis. Healthcare has got almost no tradition of international collaboration, and it's often very local, and it's conducted in the local language. So we are bringing these cultures of genomic research at scale on a global basis to healthcare delivery and precision medicine, which is very local. So we recognize the complexity involved, but you can see how we've mapped some of the Global Alliance standards to that learning health cycle. Next slide. I should say that I originally got this concept from Baron Mons a few years ago, but I probably used it every time I've done a talk since. So if in the old days, and still for many people today, the concept of data sharing is you go to a data repository, you apply for access, you download the data set, you make a copy in your local environment, and you do your work. And we're moving away from that data downloading or data copying being the way we share data for a few reasons. Probably more than anything else, scale of the data and the association with health records and health information. Those two powerful reasons for leave the data where it's generated, leave it in country, leave it in a trusted research environment, and rather than copying the data to your environment, go and visit the data where it is being well stewarded in a well-protected data repository. Next slide, please. So another animation, and I will say before we switch this on, Jan, that this one is aspirational. It's not where we are today. I don't want to create the impression that this is how the world works today, but it is a future that we could imagine if we can get the technology and the trust and the incentives to share. So if this looks beyond anything you can imagine, that's okay. We're not there yet, but perhaps see how it could be applied in Germany, inside Germany, before we stretch all the way to global data sharing. Okay, run the video.
Das Universitätsklinikum ist weltweit führend in der Krebsforschung. Anna ist Mitglied der UH-Fakultät, wo sie ein Team bei der Erforschung einer tödlichen Krankheit leitet. Wie viele Forschende möchte Anna gern mehrere Datensätze aus der ganzen Welt einbeziehen, um die genomischen und gesundheitsbezogenen Daten von so vielen Patientinnen und Patienten wie möglich zu analysieren. So lassen sich genetische Varianten identifizieren, die mit milderen Verläufen in Zusammenhang stehen und bessere klinische Behandlungsmöglichkeiten eröffnen. Auch die UH und ähnliche Einrichtungen wollen ihre Datensätze Forschenden wie Anna zur Verfügung stellen. Ohne kompatible Methoden, mit denen Forschende die für sie relevanten Daten effizient identifizieren, abrufen und analysieren können, ist dies jedoch nicht möglich. Im Moment kann Annas Team problemlos lokale UH-Daten abfragen, aber die Arbeit mit Datensätzen aus aller Welt ist eine Herausforderung. Ohne große interoperable Kohorten bleibt die statistische Signifikanz ihrer Ergebnisse gering, was ihre Fähigkeit einschränkt, das Forschungsfeld voranzubringen. Doch das muss nicht so sein. Mit einer Reihe von Software-Tools, die auf GA4GH-Standards beruhen, können Forschende wie Anna auf sichere und verantwortungsvolle Weise auf ein globales Datennetz zugreifen und dessen Potenzial zum Wohle der menschlichen Gesundheit ausschöpfen. Zunächst ermöglichen die Discovery-APIs von GA4GH den datenverwaltenden Personen, ihre Datensätze auffindbar zu machen. Anna kann dieses große Netzwerk abfragen, um Datensätze zu finden, die für ihre Studie relevant sind. Für jeden Datensatz, den sie analysieren möchte, holt Anna beim zuständigen Datenzugangsausschuss eine Genehmigung ein. Mit Hilfe der GA4GH-Standards können diese Instanzen zuverlässig feststellen, ob das Vorhaben von Anna innerhalb des ursprünglich von den datengebenden Personen vereinbarten Rahmens liegt. Ihre genehmigten Anfragen werden zu ihrer virtuellen Identität hinzugefügt. Sie kann nun mit den Daten arbeiten. Mit den Clouds-APIs von GA4GH wird Annas Labor als virtueller Knotenpunkt mit allen Daten verbunden, die sie braucht, um ihre Arbeit erfolgreich ausführen zu können. Anna sagt jedem Programm, wo es die Daten findet, welche Daten zu analysieren sind und welches Analysewerkzeug zu verwenden ist. Ausgestattet mit diesen Anweisungen macht sich die Software auf den Weg, um einen Teil der Daten genau dort zu analysieren, wo sie sich befinden. Nur Programme mit autorisiertem Zugang haben Zugriff auf diese Daten. Die Software kann Annas Anweisungen ausführen, weil die Einrichtung ihrer Daten gemäß den GA4GH Cloud-Standards auf universelle Weise verpackt hat. Jedes Programm gibt sein Analyseergebnis aus und sie alle fließen in Annas Studie ein. Als Sicherheitsmaßnahme kann die datenverwaltende Person Annas Softwareprogrammen die Zugangsberechtigung entziehen, sobald die Analyse abgeschlossen ist. Annas Team fügt die Teile zusammen, um eine genetische Variante aufzudecken, die mit besseren Behandlungsergebnissen im Zusammenhang steht. Eine neue Erkenntnis, die sie niemals hätte gewinnen können, wenn die Datensätze nicht interoperabel gewesen wären. Anna ist nur eine einzige Wissenschaftlerin, aber kein Einzelfall. Wir hoffen, dass eines Tages alle Forschenden auf der Welt bequem von ihren Labors aus auf ein globales Datennetz zugreifen und das darin verborgene Wissen über die menschliche Gesundheit und Krankheiten offenbaren können.
Jan, thanks for your help in making the technology work. As I said, it's aspirational on a global scale, but it really is very close to what those 4 leading pediatric hospitals will be doing for genomic and clinical information for rare epilepsies. It's very close to some of the federated data repositories that are being linked together in Europe as we speak. So it's on a global scale, every hospital being able to do this every day. We're a decade or more away. And in terms of some examples today, we're getting very close to real world. Final messages for you, lots of ways to contribute to GA4GH. I won't read them all, but we need people in all of those roles from all countries with all their expertise. And it is an open, inclusive, welcoming community. Next slide. And I would just invite all of you, collectively as a group or individual, join a work stream, get involved, subscribe to our updates, come to our meetings. The next Connect meeting we'll be holding in April of 2024, and our next plenary is Melbourne the following year. I think that might be the last slide. Oh, just to say, when you wrap it all together, this is the community at many levels. And we do have this small legal entity called GA4GH Inc., but it really is to just keep those funders and host institutes together so we can support the entire community globally. Thank you.